Hello, my name is Tiana Ringer, and this is my forensic engineering project for Mechanics of Materials class. I researched the St. Francis Dam failure. The St. Francis Dam was located north of Los Angeles in the San Francisco Canyon and was built from 1924 to 1926. The dam was built and failed during the same time frame as the California water wars, where the city of Los Angeles was in conflict with farmers in the Owens Valley for the city's expansion and diversion of water for the Los Angeles Aqueduct and other projects. This is important to note because William Mulholland was a key visionary of the aqueduct, and it was built under his supervision and completed in 1913 prior to his work on the St. Francis Dam. William Mulholland was chief engineer of the Los Angeles Water Corporation from 1886 to 1902. Afterwards, he was chief engineer and general manager of the Los Angeles Bureau of Waterworks and Supply from 1902 until 1928, which was when the St. Francis Dam failed. He had worked on embankment dams and only one previous concrete dam, which was the Mulholland Dam from 1923 to 1925. Mulholland is considered the main face of the dam's failure. The St. Francis Dam began construction in 1924 and was completed 2 years later in 1926. 2 years after its completion, on March 7, 1928, the reservoir was filled just 3 inches below the crestway. A few days later after this, on March 12th, the dam keeper discovered that there was a leak in the western abutment. William Mulholland and his assistant Harvey von Norman came to inspect the leak, however, came to the conclusion that it was due to a fresh cut of an access road right by the dam. They estimated that the leak was 2 to 3 cubic feet per second. However, later on, their record was considered to be inconsistent. Later that night, at 11:50 p.m., a witness hears the dam break. And just a few minutes later, the dam had collapsed with a landslide of the eastern abutment and began to flood the San Francisco Canyon all the way to the ocean. The main investigation for the dam's failure was on March 19th, just a week after its failure. The team was appointed by California Governor C.C. Young and had 2 geology professors and 4 engineers. They spent 1 day on site, 2 days going over documentation, and 2 days writing a report. There were several technical flaws that led to the dam's failure. First off, the design of the dam was essentially copy and pasted from the Mulholland Dam, with only minor changes and no significant calculations were done. The dam was built in contact with the Vasquez Formation of rocks, which is a thick sequence of sandstone, conglomerate, and breccia rock, which can experience slacking or disintegration when underwater. The landscape was not tested to see if it would be suitable for building a dam. Along with this, there was not enough research done on the effects that concrete experienced with high-pressured water. The idea of hydrostatic uplift was only really discussed after this dam's failure. The hydrostatic pressures on the dam lifted it up from the base, then causing the rest of it to fail. The biggest error in building this dam was a year into construction in 1925, 10 feet of height was added to the dam without widening the base. The majority of the blame for the dam's failure is on William Mulholland's shoulders. He was a self-made engineer who had minimal education and minimal experience building concrete dams prior to the St. Francis Dam. He also did not have any outsiders come in and test or approve of the dam when it started to fail. There should have been a lot more safety precautions taken in the building of this dam. There were not enough tests done on the foundation of the rock, which eventually washed away. There was not proper calculations or adjustments made to the design when it was moved to this new location. The dam was filled way too close to the maximum load, just days before its failure. There was also an overall lack of external testing and approval from outside sources. After the dam's failure and investigation, William Mulholland faced criminal prosecution by Los Angeles District Attorney Asa Keys, who said in the final jury statement that the construction of a municipal dam should never be left to the sole judgment of one man, no matter how imminent. However, Mulholland said to not blame anybody else. You just fasten it on me. If there's an error of human judgment, I was the human. While he took personal responsibility for the failure of the dam, it showed that there were other aspects of the dam that needed to be highlighted for the future of engineering. The dam's failure drew attention to the importance of needing engineering, geology, and civil engineering curriculum. In 1929, California enacted a professional registration for civil engineers to help prevent errors like this in the future. The idea of hydraulic uplift was greatly debated after the dam's failure, and engineering texts then began to teach how to take into account an uplift force on gravity-driven dams. Concrete was also began to be analyzed while wet and not just dry, because the resulting thrust forces would be different on the concrete. The most prominent failure category for the St. Francis Dam was negligence. There was a lack of testing, forethought, and action when issues started to appear. The second biggest failure category would be miscalculations. There was an inability to calculate the hydraulic uplift on the dam, and there was also a failure to make adjustments to the dam after adding a significant amount of height. The biggest takeaway for engineers with the St. Francis Dam failure is that engineers cannot underestimate complexities of a design situation. It's important to take the time to do all of the calculations and all of the testing, as well as to have an outside source check your work for you. When this is not done, many people can die and property can be damaged. In this case, there was an estimated 400 plus people dead, with many people left unidentified. The engineering mistakes ended up being a tragedy, which could have been avoided. In conclusion of this presentation, it is important for engineers to understand that their decisions in the engineering process will have effects on the lives of many different people. It's important to do things correctly and to not rush them in order to protect the sanctity of life of people.